Today we'll be looking at designing and training a basic neural network model. We'll look at the steps that we follow and see that designing and training a basic neural network model involves several steps. We'll be looking at these steps. So welcome. So the first step in designing a neural network model is defining the problem. We need to clearly state the task that you want the neural network to perform. This could be a classification, a regression, generation, anomaly detection, etc. So first of all, you need to clearly state the task that the neural network will solve or will perform. We need also to define the input features and the corresponding output that we expect from the neural network. We also need to clearly define the metric that will be used to evaluate the performance of the neural network. Then you identify any constraints or limitation that might impact the problem or the neural network solution. This could include computational resources, time constraints, or ethical consideration. So you need to put in consideration any constraints that may impact our solution. And we also need to, we see that problem definition is often an iterative process. As you work with the data and the model, you may need to refine your problem statement based on insights gained during the analysis. So when you are doing this, defining the problem, remember it's an iterative process that is like a loop. You may need to go back and check as you are working in the data. If you realize something that is not working, you can come back and rectify. Yeah, so that is the first step, that is defining the problem that you want the neural network to solve. The second step is collecting and preparing the data. Remember, you'll be working with the data in the training or in the designing. Now you need to collect and prepare the data. And you see that in this stage, we gather the relevant data for training and testing. And we ensure that the collected data is the representative of the problems and diverse enough to capture different scenarios. We should process the data by cleaning, normalizing, and transforming it as needed, that we can usually use in the model. So we need to divide the data set into training, validation, and testing sets, ensuring that each split is a representative of the overall set. Ensure that the data collection and storing adhere to privacy and security regulations. So where you store your data, ensure that it maintains the privacy and security, but it will not expose to unauthorized individuals. Step number 3 is to choose a neural network architecture by the designer. So you should select the type of neural network architecture that best fits the problem that you want to solve. You can familiarize yourself with the existing neural network architecture specifically in CNNS. You can do some research, try to get with the previous architectures that have been successful in such a task that you want to solve. You see that you should also avoid overly complex models or simpler tasks, or when working with limited data. You should not go and pick very complex models if you are just solving a simple task. Use a simple architecture for simple tasks that you can even save on resources and also ensure that you get access to the problem that you are solving. For beginners, a feed-forward neural network is a good starting point. Yeah, so just start with a feed-forward network. You can use deep learning libraries like TensorFlow or PyTorch to define your neural network model. But remember, simple architectures are often more interpretable and easier to train. And that choosing a neural network architecture is not a one-size-fits-all process. So you should regularly evaluate and adjust your choices based on the performance metrics and insights gained during the training process. So we see that the script gives a simple architecture for simpler tasks, and it's also not like something that you do just once. You need to consider the insights that you get along the way, so that you can be able to even make rather like a change in the feature that you're choosing. If you realize that you will not be able to solve your problem. So that is it. That is the step number 3. So we go to step number 4, whereby we define the input and output layers. So we need to define the input and output layers that and this we see that we design the input layer based on the features of your data. That is, depending on the nature of the data that which will guide you on how to design the input layer. The output layer is designed based on the nature of the problem. That is one node for binary classification, multiple nodes for multi-class classification. And you see that the number of nodes in the output layer depends on the number of classes for classification tasks or the number of the output values for regression tasks. So the output layer design is guided by the nature of the problem that we are solving, and the input layer is defined by the type of data that we have. And you should remember to tailor the input and output layers to the specific problems, the requirements of the specific problem that we are trying to solve. Yeah. So remember to map those two depending on the type of problem that you are using, you want to solve, and also the kind of output that we expect. Yeah, so that is about the defining the input and the output layers. So we go to step number 5, which is configuring the hidden layers. Remember, we have some hidden like the network with an input layer, hidden layers, and the output layer. Hidden layers can be many. So we need also to configure the hidden layer. It is often a good practice to start with a simple architecture and gradually increase complexity if needed. This helps avoiding overfitting and ensures that the model isn't unnecessarily complex. So it's good to start with simple architecture. Remember this problem of overfitting and underfitting, we look at it later as we progress. If using a multi-layered neural network, decide on the number of hidden layers and the number of neurons in each layer. So as I say that hidden layers can be many, so you should decide how many they should be. Experiment with different configuration based on the performance metrics. Yeah, check on the performance metrics. If you observe them, you can now decide which will work best. This is the number of hidden layers. If your model is underperforming, you may need to increase complexity. If it's overfitting, consider reducing complexity or adding regularization. So we say that if working on a related task where pre-trained models are available, yeah, consider using transfer learning. Okay. So if you do some research and you find that there are some existing pre-trained models for the task that you want to solve, you consider using transfer learning because fine-tuning a pre-trained model can save training time and resources. So if you have a pre-trained model, then you can save on your time and resources. But you should ensure that pre-trained model was solving a similar task that you want to solve. Huh? Yeah, that is on that is on the so we go to another step, that is initializing the weights and the biases. Very important step also. Initializing steps and biases. Uh, so initialize the weight and biases of the neural network. Common methods include zero initialization, random initialization, solution to change weights if applicable. Experiment with different initialization techniques to find what works best for your specific neural network architecture and the problem. So the initialization of weight and biases will depend on the specific problem that you want to solve and the structure that we chose. Yeah? So it will be a guiding factor. And we say that the proper initialization of weights and biases is crucial for training a neural network effectively. Poor initialization can lead to slow convergence, vanishing or exploding regions, and suboptimal performance. So you should ensure that you do the initialization properly. Yeah, very crucial for training a neural network effectively. And remember, I talked about weights and biases in the previous chapters. So if you forgot something about them, you can go back and refer to them. Gives the importance in the neural network. So we go to step number 8 where we choose a loss function. We need to select a loss function. And we say that if you select a loss function that measures the difference between the predicted output and the true target. Yeah. The predicted output and the true target. The choice of a loss function depends on the nature of your problem. If is, for example, mean squared error for regression or cross entropy for classification. So if you are doing regression classification, then you use loss function depending on the classification. It will be different. The loss function used during training might not be the same as the one that is used as the evaluation metric. So the loss function used during training might not be the same as the evaluation metric. You should monitor additional metrics like accuracy, precision, cost during training to ensure a holistic evaluation. And you see that the choice of output activation function often influences the choice of the loss function. Yeah, the output of the activation function usually influences the choice of the loss function. For example, sigmoid activation function with the binary cross entropy for binary activation, softmax with categorical cross entropy for multi-class classification. So the output of the activation function will affect the choice of the loss function that you choose. So let them be your guiding factor in choosing a loss function. Yeah. The next step is choosing an optimization algorithm. And the choice of the optimization algorithm depend on factors such as the size of the dataset, the nature of the dataset, the architecture of the neural network, and the computational resources available. Those are the guiding factors when choosing an optimization algorithm. So you see the decision you made on the architecture or the size of the data or the nature will impact the optimization algorithm that you choose for your model. Choosing an optimization algorithm that is, you need to choose an optimization algorithm to minimize the loss function during training. Yeah? And it is common to experiment with different optimizations and the hyperparameter to find the combination that works best for a specific task. Yeah. So that is about choosing an optimization algorithm. And to say that the guiding factors should be the size of the data set, the nature of the data set, architecture of the neural network, and the computational resources available will be able to guide you on which optimization algorithm you can set through on. Step number 10 is training the model. Now we need to train the model. And we see that training a neural network involves the process of adjusting the weights and biases of the networks to minimize a specified loss or cost function. Yeah. And this is typically done through an optimization algorithm, as discussed in the previous slide. Adjust the hyperparameters stop tuning with the model of a or fails to converge. And you should experiment with different learning rates, batch sizes, and other hyperparameters to find the optimal configuration. We should also adjust hyperparameters or stop tuning if the model overfits or fails to converge. Okay. So as I said before, you will be looking at the overfitting and underfitting as we progress. You can be able to understand more what it means to overfit or underfit a neural network model when training it. So that is a very important step. That is on the training of the model. After you train now you evaluate. You need to evaluate the model. And evaluating a neural network model involves assessing its performance on a test data set using appropriate evaluation metrics. So we need to evaluate if this our model is performing the task as we wanted it to perform, and we should compare with the metrics that we have. So first of all, adjust the code based on your specific use case and requirements. And we say that evaluation of a model usually begins with splitting the data available into three sets, that is the training set, validation, and the test set. We train our models on the training data, so we use the training data to train, evaluate them using the validation data, and once our model is ready to be deployed in the real world, now we use the test the data, to test it if it will perform, how will it perform in the real world now, the test data. So that is all about the evaluation model. That is not like our evaluating, that is assessing the model performing and how best is it performing the task that you wanted it to perform. Step number 12 is tuning and optimizing the model. You need to tune and optimize it. You have validated or tested it, evaluated it. Now you need to tune and optimize the model. We say that if necessary, fine-tune hyperparameters, adjust the model architecture, or experiment with different optimization techniques to improve performance. So depending on how the results from the evaluation, you may need to fine-tune the hyperparameters, adjust the architectures so that it will improve on the performance. You should use learning rate schedules or adaptive methods for automatic adjustment during training. Adjust the complexity of your model based on the size of your data set. Monitor the model performance on a validation set during training. So ensure that you use the validation set. And always remember to validate any changes using a separate validation set and ensure that your improvements generalize to unseen data. So the last step is deploying. You need to deploy now the model in the real world. Deploying a neural network involves making your trained model available for predictions in a production environment. Ensure that the input data in your production environment is pre-processed in the same way it was done during training. This includes scaling, normalization, and any other pre-processing steps. Consider deploying your model on cloud platforms like Google Cloud, Azure, AWS. For scalability and ease of management, you can use the cloud platforms. Thoroughly test your deployed model to ensure that it performs as expected in the production environment. So you need to thoroughly test your deployed model before it starts being used. Ensure that you test it in the production environment to ensure that it's performing effectively. Remember the specific steps for deployment may vary based on your infrastructure and the requirement, but always consider the security, scalability, and maintainability aspects when deploying a neural network model in a production environment. We should note that designing and training neural networks is often an iterative process that involves experimentation and fine-tuning to achieve the desired results. So it's not just like a waterfall model, it's an iterative one. You can go back and check on and change a few things, then go forward. You move on the steps on training the neural network.